Hello everyone, this is my third video in the quadrilateral series. In this series, we are figuring out the properties of quadrilaterals. In my first video, we discovered that when the diagonals are equal and they bisect each other at right angles, we get a quadrilateral known as a square. We called it a perfect quadrilateral because its properties are the perfect ones. Sides are equal, vertex angles are 90 degree, diagonals are equal, diagonals bisect each other at 90 degree. In my second video, we did a little experimentation and we increased the length of one of the diagonals. So here, when we increase the length of one of the diagonals, like the length of one diagonal is more and the second diagonal has lesser length. That means the diagonals are unequal but they are still bisecting at 90 degrees. Bisecting each other at 90 degrees. So we get another quadrilateral. Just by changing the length of one diagonal, we get another quadrilateral. This is the beauty of quadrilaterals. We are changing the combination, we are trying out different combinations of diagonals and we are getting different quadrilaterals. So this time you can also think what change to make in the diagonals. What I have thought is that the diagonals would cut each other at 90 degree, but one of the diagonals will be bisected and the other will not be bisected. So let's try out with this combination of diagonals. I'll just clarify what I mean to say. I mean that suppose I make a diagonal, one of the diagonals as 6 units. The length of one of the diagonals I am going to take as 6 units. This is the first diagonal. Now the second diagonal I am going to draw with a different color. Now it's going to cut this diagonal at 90 degree only, but it will not bisect this diagonal, but it will itself be bisected. Let's see how. Now I have chosen the length of the other diagonal to be 4 units. So I will make it in such a way that it gets bisected. Let's see how I am going to do it. I am going to make 2 units this side, 1, 2 and 2 units length of this side. So you can see the purple diagonal is getting bisected and it is getting divided into 2 parts by this brown diagonal. But the brown diagonal is not getting bisected. See, 2 units this side and 4 units this side. But they are meeting each other at 90 degree only. Now, by intuition, I can tell that this length and this length are equal. See, if you can also imagine how this diagonal and this diagonal, it is dragging the side to this point and this point is dragging it to the same point. So let's see and we'll check also whether our intuition is correct or not. So let's join the end points. So I am using the same color for these 2 sides. I will check the measurement. It's roughly around 4.6. Let's check the other one also. Yes, around 4.6 only. So that means like you can also think by intuition first and then check whether your intuition is correct or not. You may also think of some other ways of proving that this red lines, these sides are equal by congruence or by any other way. Just think about them and just put your comments in the comment section. I would be waiting for those. So I now also, my intuition tells me that the other two sides are also going to be equal. So I am just drawing with the same color, and later on I am going to check it. So let's see. It's roughly around 3.3 only. It's around 3, and this is also 3. So we can see. So have you seen this shape anywhere? Just write in the comments if you have seen this shape anywhere. I can give you a hint. You must have seen it in the skies. Okay. So now keep one diagonal is getting bisected. The diagonals are unequal and they are cutting each other at 90 degrees. This was one kind of thing that we got. Now just imagine if I reduce the size of this brown diagonal, what will happen? So of this shape only, this particular quadrilateral, different possibilities are there for this particular quadrilateral. So that you can try to draw and see what happens. One we can draw. I'm going to take some other dimensions for both the diagonals. Let's see what happens. The brown one I'm going to take. I'm taking it 4. Let's see what happens. I've not thought it beforehand. And the purple one. Let's see. I think I am trying to bisect this one. Or maybe I can bisect the brown one this time. And if it gets bisected and the other one's not going to get bisected, but it's going to meet this brown diagonal at 90 degrees. So I make it like this. I can see a similar T kind of a thing which I got here. And I can by intuition say that this side and this side, they are going to be equal. And this are going to be equal. Let's check it out. Let me measure it. 4. Yes, 4. Yes. Now, are these two shapes of the same kind? This is my question. And if they look a little different to you, how are they different and how are they same? So this is what you need to think about. But here, for the purpose of this video, I'm going to tell you the name of this quadrilateral. It is, I told you, I gave you a hint that you can see it in the skies. So it is called the kite. Now different kinds of kites are possible. You just play around with the diagonals and find out different kinds of kites, and please let me know. So now we are going to write our set of properties in our foldable, which we have created in our previous videos. So let's do it for the kite also. Yes. First, the sides. What do we know about the sides? Now, you will say, ma'am, these red ones are equal and the green ones are equal. What is the name of, how are we going to tell people that a kite has these two sides are equal and these two sides are equal? So we say these are adjacent sides. Like they are coming next to each other. They are not opposite. These are the opposite ones and these are coming next to each other. So they are the adjacent sides. So we say that adjacent sides of a kite are equal. So adjacent sides are equal in a kite. Now, one question is coming in my mind. Why is this quadrilateral only used for flying in the sky? Why not any other quadrilateral? Just think about it and let me know in the comment section below. I would be waiting for your answers. Now let's look at the angles. I am having a protector with me, but if you need to figure out the angles without the use of protector, so can you just think about the angles? Are all the angles equal? First question is, are all the vertex angles equal? So you will say that, ma'am, no, this one is opening less, this one is opening more, and so they are not equal. They don't seem to be equal. So what can be the relation between the angles? Just think for a minute and then we'll check with the protractor. Now what does it feel? These two angles, they don't seem to be equal, because this diagonal is making it go to this point and this to this side, but this has to move lesser distance and it is opening more. So these don't seem to be equal. But now look at these two angles. They seem to be equal. This is my intuition, which I am just thinking about the way the sides are opening and the way the diagonals are kept. So let me check my intuition using the protractor. So this one is roughly around 105. So let's check the opposite angle. It is also 105. So let's check out these angles. Let me check this one. How much is this angle? It is roughly around 55. So this one is around 55 degrees. Let me check the opposite angle. So I'll be measuring from the lower reading and it is around 90, 92, 93. So this one is around . So let us check this angle. So we'll be taking up the lower reading here. So it is more than 90 degree. It is around. So we'll be taking the lower reading and it is more than 90 degree, around 93 degrees. So that means our intuition was correct that these set of opposite angles are not equal. Now let's check this angle. It is around 105 degrees and this one also. It is also around 105 degrees. So we see that these opposite angles, one pair of opposite angles are equal but not the other pair. So this is one property of kite which I am going to put it down on my foldable. that the vertex angles one pair of opposite vertex angles are equal. So now which pair is this that you need to think? Always when you look at a kite, so you can imagine or you can think by intuition that which is that pair. Now let's talk about the diagonals. In the beginning we fixed two conditions, that the diagonals will cut at 90 degree and one of the diagonals will get bisected. So this one is getting bisected in this case and the brown one is getting bisected in this case. If you look at these two kites carefully, in this kite the diagonals are unequal. See, the brown one is of 6 units and the purple one is of 4 units. But in this kite the diagonals are of equal length, 4 and 4. So diagonals as such, they can be equal or unequal. So this is not a condition. So the only two conditions which are there are necessary conditions which are there are that the diagonals should cut each other at 90 degree and one of the diagonals should be bisected. So here I am going to write on my sheet foldable that the diagonals cut each other at 90 degree, and the other condition which is necessary is that the diagonals, one of the diagonals gets bisected. So these were the properties of kite. So if you have understood and this video is useful for you, then please subscribe my channel for future videos, and thanks for watching. Goodbye.